Hey guys, welcome back. Today let me give you a situation. Let's say that you are working in a tire company and you need to find out the optimum grip of a specific tire. You know that there is some relation between the tire temperature and you do have the data of the tire temperature, the various temperatures of the tire. So you just need to determine at what temperature the tire will have the optimum grip. So now yeah, we know that there's always the relation between the grip and the tire temperature and all that stuff. But today in this video, we'll see what actually this relationship is. One method of finding out the optimum grip is plotting a graph of G-force versus the temperature. So here we have the G-force on the y-axis and the temperature of the tire on the x-axis. When the vehicle is running, the data is collected, it is monitored, and a graph is plotted. For example, here we can say that the graph is something like this. So here we can say that the temperature of the tire, the grip of the tire is maximum at somewhere around like 45 degrees Celsius. Well, this is just an explanation, and in real case, it's somewhere like more than this, of course. But just to understand, this is how it can be done, plotting a graph between between the G force and the tire temperature. But now here's the deal. This is just for one tire. You need to plot such particular graph for four different tires. Well, let's say you also did that. You have four different graphs. So such graphs, like, with such kind of curves, you have four different kind of curves. And you also determine the optimum grip in each and every tire. But now if you are told that you need to see the relationship between those tires, for example, if those tires work together or coordinate together, to be specific, so how can you determine that thing and how can you take that into consideration? We'll see here. Now we know that one axle has two wheels. Well, that's quite obvious. I don't need to tell that to you. But in order to understand this grip temperature thing, we need to understand that on one axle, as the two tires have to be, they need to work in coordination. And by that, I mean, let's say we have this on x-axis, we have the distance of the track in kilometers, and on y-axis, we have the temperature difference. Now here I am saying the word temperature difference, and this difference is the tire temperatures. For example, if I am taking the front axle, then the temperature difference between the front right and the front left axle. So let's say it can be from 0, -10, -20, -30, and same in the positive side, on the positive side. So understood till here, like this axis is all about the temperature difference of one axle. And this is, let's say, the track is like 5 kilometers in distance. Yeah, so quite easy till here. Now what we'll see for the first lap, for the first kilometer, let's say the temperature of the tire, both the tires on the front axle, for example, was almost same. So there was hardly any difference, and the line is going straight. So somewhere along the track there was some maybe skate or drifting or something like that. So maybe there was a little bit difference, and so on goes the graph, like, it can go, there can be difference, a huge difference. So now if the temperature difference between both the tires is zero or near to zero, we can say that the tires are working in coordination. But the thing doesn't end over here. This was just about the front axle. Okay, now talking about the rear axle, that will be the same graph, the temperature difference between the two tires versus the distance of the track. Now let's say that surprisingly the tires on the back axle have almost zero difference in tire temperature. along the track. Okay, that's quite a good performance. Now here's the deal. Here's the main deal where you need to, you know, take the things important. Here we see, like for example, let's say we completed 2 kilometers. So here see the wheels on the rear, the tires on the rear axle maintain zero temperature difference. But the same on the front axle, they have this, this curve on the positive side. Because of this, there can be some, you know, instability in the vehicle because the front tires won't work optimally, whereas the rear tires are working quite good. So there'll be some problem. Now, why does this occur? Well, there can be many reasons. For example, there can be a problem in the differential, the limited slip differential, or also there can be problem with the camber or whatever. Like you can understand why the temperature of the temperature of the tire can rise. There may be some drift, or there may be some a sudden braking action or whatever. So the main point over here is the difference between the two tires on one axle should be almost zero. Secondly, if we compare these two graphs, that is of the front axle and the rear axle, they both should have, like, if the rear axle is having the straight line at one particular point, then so should the graph of the front axle. Now, this was all about the tire temperature and the optimum grip. Now, just a quick recap. First, we discussed about a small curve, and it was like the temperature versus the G-force. Quite good. We can use that also, but that is too time consuming. You have to take the graph of all the four wheels and then compare them and all this stuff. Here you are getting the temperature difference. We have tire temperature sensors. You can utilize them, and you'll get a graph plotted on your monitor, and you just need to compare the graph, and hence you can know the performance, how the tires are performing on the track. I hope you understood this video and liked it too, and thanks for watching it, and see you in the next video.